Hi viewers, welcome to Learning Electrical Engineering channel. In this video, we will see about mesh analysis. Mesh analysis providing a generalized procedure for solving and analyzing the circuits. The mesh analysis is applicable only for planar circuits. Now we need to know what is planar circuit. For example, we need to consider this circuit. In this circuit, the two branches 5 ohm branch and 6 ohm branch is crossing the another branches. But when we redraw the circuit, it will be look like this. And in this circuit, the branches 5 ohm and 6 ohm, when we redraw this will be looking like this. And these branches are not crossing any other branches, so we can call it as a planar circuit. We must remember one thing: the mesh analysis is only applicable for planar circuits only. Now we need to know what is mesh. Mesh is a loop. We will write here what is mesh. Mesh is a loop which does not contain any other loops within it. In this video, we will see mesh analysis in two steps: mesh analysis without current source and mesh analysis with current source. For solving a circuit, we need to follow the certain steps in mesh analysis. Step 1 will be marking of loops and loop currents, or we can say the mesh currents. And second one, we need to apply the KVL. So in mesh analysis, we need to apply the KVL for the loops to obtain the equations. And third one, KVL for loops to obtain equation. And third one, solving of equation to find out the circuit variables. Now on the first step, we will consider a circuit which is having two voltage sources, that is V1 and V2, and the resistors R1, R2, R3 like this. And we will mark the loops, that is A, B, C, D, E, F. In this, A, B, E, F will form the loop 1. We will write this is loop 1, and the current in the loop 1 will be I1, and the direction is as shown in the circuit diagram. And B, C, D, E form the another loop. We can call it as the loop 2, and the current in the loop 2 will be I2, and the direction of current is as shown in the diagram. And the branch currents will be capital I1, capital I2, capital I3, and this is the currents flowing through the capital I1, that is the branch current is flowing through R1, and the current flowing through R2 will be capital I2, and current flowing through R3 will be capital I3. These capital I values are branch currents, and loop currents will be small I1 and small I2. Now we need to apply the KVL in loop 1. Apply KVL to loop 1. What is the loop 1? Loop 1 is formed by A, B, E, F. Okay. Now in loop 1, when we applying the KVL, and here one more condition we must note, that we should use only the mesh currents, that is small I1. When we applying the KVL to loop 1, the current flowing through R1 will be small I1, so we can write small I1 into R1, and the current flowing through the resistor R3 will be one loop current I1 is flowing in this direction and the loop current I2 is flowing in opposite to that of the I1. So we need to write here as the voltage drop across R3 will be what? The difference of current, that is I1 minus I2 into R3, and further the arrow will meet the negative terminal of the V1, so we can write negative V1, which is equal to 0. This equation is obtained by applying KVL to loop 1. Now when we simplifying this, we need to transfer the voltage terms to one side and current I1 terms to one side, one place, and current I2 terms to one place. When we solving this equation, when we simplifying this equation, I1 into R1 plus I1 into R3 minus I2 into R3, which is equal to V1. Now on further simplification, we can write I1 into R1 plus R3 minus I2 into R3, which is equal to V1. Say this is equation number 1. Now apply KVL to loop 2. When we applying the KVL to loop 2, apply KVL to loop 2. Now we are going to apply the KVL to loop 2, that is B, C, D, E. In this loop we are going to apply the KVL. Now the voltage drop across the R2 will be I2 into R2, and the arrow which meets the positive terminal of the V2, so we can write positive V2, and next again this arrow meet the R3. Next the current flowing through R3 will be, both the currents are flowing, that is I1 and I2. Now we are in the direction of I2, so we will take I2 minus I1. This is the amount of current flowing through R2, so we can write that the current flowing through R3 will be I2 minus I1 into R3, which is equal to 0. In the same manner as above, we need to segregate the I1, I2 values and V2 values. So on simplification, we will get the value minus I1 into R3 plus I2 into R2 plus R3, which is equal to minus V2. So say this is equation number 2. Now we need to solve the equation 1 and 2 to find out the mesh currents. For solving of these equations, we are going to apply the Cramer's rule. Cramer's rule. In this, we will form the matrix. From this matrix, for I1 term we can write R1 plus R3, and for I2 term we can write minus R3, and from the equation 2 the I1 term will be minus R3 and I2 term will be R2 plus R3, and we need to mark the currents here, that is I1 and this is I2, which is equal to the voltages, what is V1 and minus V2. V1 minus V2. On solving this matrix, we can find out the mesh currents. Okay. Now we can apply the mesh currents to find out the branch currents. From this circuit diagram, we know that the mesh current I1 is equal to branch current I1. So we can write the mesh current I1 is equal to capital I1, and the mesh current I2 is equal to branch current I2, and for the branch current I3, the two loop currents difference will be I1 minus I2 will provide the branch current I3. Now, from the Cramer's rules matrix form, we have found the mesh current values I1, I2, and from this we can easily find out the values of branch currents. Next, we will see the mesh analysis with current source. In this mesh analysis with current source, we will have one current source here, that is 5 amps current source is connected on the loop 2, and a 10 voltage source is connected in the loop 1. As we discussed earlier, say this is A, B, C, D, E and F, and this the A, B, E, F will form the loop 1, and B, C, D, E form the loop 2. Here we are having the numerical values. Now we will solve these numericals also. As per KVL, when we are applying KVL to loop 1, KVL to loop 1, we can say that the 4 small I1 plus this is the voltage drop across the 4 ohm resistor. We don't know the value of current flowing through it, so the mesh current is I1 and the arrow direction is as shown in the diagram. Now when we marking the arrow from here, it is meeting the positive potential of the 4 ohm resistor, so the 4 I1 will be the positive, and here the two currents is available which is flowing through the 6 ohm resistor, that is loop current I1 and loop current I2, but both are in opposite direction, so we can write that the value of resistor is 6 and difference of current I1 minus I2, and finally the loop direction is meeting the negative potential of the negative terminal of the voltage source, so we can write 10 which is equal to 0. From this equation we can simplify, on simplification we can find out that 10 I1 minus 6 I2 which is equal to 10. Now this is equation number 1. Now when we seen with the current source which is connected here, the circuit can be solved very simply, because the current I2, that is mesh current direction, is downwards, and the current source is flowing in the upward direction, so the current direction, the I2 current value will be minus 5. Say this is equation 2. When we applying the I2 value in equation 1, we can find out the value of I1, that is mesh current I1. So 10 I1 minus 6 into minus 5 which is equal to 10. Now the value of I1 is equal to, this 10 is there here, and the 6 5s are 30. When we transferring to right hand side of this equation, we will get minus 30 divided by 10. So the I1 value will be minus 2 amps. The I1 value will be minus 2 amps. This negative term indicates that the current I1 direction is opposite to that of the marked direction, so it is in this direction. Okay, now I2, the I2 we know that this is minus 5 amps, so the I2 direction is also in this direction. Now we know the mesh current values. Now we know the values of mesh currents I2 and I1. From this, branch currents can be find out. So the current through 4 ohm resistor, current through 4 ohm resistor is equal to 2 amps. Okay, now the current through 3 ohm resistor is equal to, that is 5 amps. Current through 6 ohm resistor, current through 6 ohm resistor, that is this resistor, is equal to difference of mesh currents I1 and I2. So the difference will be -2 plus 5, which is equal to 3 amps. The current flowing through 6 ohm resistor will be 3 amps. So we can mark it here. The current is 2 amps in this direction, and current through 3 ohm resistor will be 5 amps in this direction. The current through 6 ohm resistor will be 3 amps in this direction, because when we applying the KCL to at this node, the incoming current is 5 amps and outgoing current is 2 amps plus 3 amps. So in this way we can solve the equation, and we can find out the branch currents in terms of mesh currents. Now when we proceeding further, if the current source is connected between the two loops, that is common to both the loops, then this will form the super mesh. The super mesh is having certain properties, that is the super mesh properties we can write here. Super mesh properties. The first property will be, it has no current of its own. Second, it will provide a constraint equation to, and third one, we need to apply KCL and KVL to solve the circuits. Now these are the super mesh properties. We can recall once again. When the current source is connected between the two loops or common to two loops, that time this will form the super mesh, and this super mesh having certain properties. That is, first one is it has no currents of its own. Second one, it will provide a constant equation which can be used to solve the further equations which was drawn from the circuit diagram, which was obtained from the circuit diagram by applying the KVL. And third one is we need to apply KCL and KVL to solve these kinds of circuits. On to solve these kind of super mesh circuits, we need to remove the current source and the resistors or the any other element which is connected in series with the current source, because to apply the KVL we need to know the voltage values which is across the current source. At present we don't know the value of current source, so we can remove this super mesh and we can redraw the circuit like this. When we redrawing this circuit like this, and we need to apply the KVL to this equation, to this circuit diagram. When we applying the KVL, and we need to mark the arrow direction like this, and the loop mesh current is I1 and mesh current is I2. The mesh current I1 which is flowing through 6 ohm resistor, and mesh current I2 is flowing through the series connection of 10 ohm and 4 ohm resistor. Now the direction of arrow is first meeting the positive terminal of the 6 ohm resistor. So the value, the voltage drop across the 6 ohm resistor will be 6 into I1, and next the arrow meets the 10 ohm resistor and 4 ohm resistor which is connected in series, and current flowing through these two resistors will be I2, that is mesh current I2. So we can write the positive 14I2, and finally the arrow meets the negative terminal of the voltage source, that is negative 20, which is equal to 0. So we can write 6i1 plus 14i2, which is equal to 20. Say this is equation number 1 for this method. Okay, now we need to find out the value of I2. So for finding out the value of I2, we need to apply the KCL here. Okay, on applying the KCL, the incoming current to the node, KCL to a node, that is this node. So when we applying the KCL to a node 0, the incoming current is I2 and the outgoing current is I1 plus 6 amps, that is the current source. Say this is equation number 2. When we applying the equation number 2 to equation number 1, we will get 6i1 plus 14 into I1 plus 6, which is equal to 20. Equation 2 in 1. Apply equation 2 in 1, we will get this equation. On further solving, we can get I1 is equal to minus 3.2 amps and I2 is equal to 2.8 amps. Okay, now from this mesh current values, we can say that the current flowing through the 6 ohm resistor will be in this direction, that is 3.2 amps is flowing towards voltage source. The current flowing through the 10 ohm and 4 ohm resistor will be I2, this is the mesh current, and the mesh current I2 will be 2.8 amps, which is in the same direction. So we can write that 2.8 amps is the current flowing through the 10 ohm and 4 ohm resistors, and the current flowing through these 2 ohm resistor will be 6 amps. Here 6 amps is flowing, and from here the current is getting divided. 3.2 amps of current is flowing through 6 ohm resistor and 2.8 amps of current is flowing through 10 and 4 ohm resistors. This is how we can solve the circuits using the mesh analysis. If you like this video, kindly hit the like button below this video. If you have not subscribed my channel, kindly subscribe it. If you have any doubts, kindly put it on comment box. I will reply it. Thank you so much.